Assalamualaikum and salam sejahtera. So today, we from Group 6 will be presenting about AM and FM modulation, simulation, bandwidth, and noise performance analysis. So our group members are Lu Ik Shen, Lim Wei Chuan, me, Nur Yasmin Yusra, and also Kamalia Sofia. In our presentation today, we will cover the introduction for AM and FM, theoretical background, amplitude modulation, frequency modulation, the bandwidth analysis, noise performance analysis, AM and FM comparison, and also the real-life application for AM and FM. So what is analog modulation? This refers to the process of encoding information signals, for instance audio or video, onto a continuous wave carrier signal by varying one of its parameters. So in this definition, it is stated that it modifies a carrier wave either in amplitude, parameter, frequency, or phase to carry the information. There are two types of analog modulations, which are amplitude modulation and also angle modulation. Angle modulation is separated, divided by two categories, which is frequency modulation and also phase modulation. While in this presentation, we will focus more on frequency modulation. So both amplitude modulation and frequency modulation are vital aspects in analog communication. However, each of these modulations serves a better purpose for a certain application and has better benefits than the other. For amplitude modulation, it varies the amplitude of the carrier signal, and its advantages are it has simple circuitry, and it can cover a large geographical area, which is why it's very commonly used in broadcasting. But the disadvantages are it has a low noise resistance, um, stating that it is um, easily disturbed with environmental noise. For frequency modulation, it varies the frequency of the carrier wave, and unlike AM, it has a higher noise immunity, which can produce better sound quality. However, the disadvantages is it uses more bandwidth in the modulation process. So I will explain briefly about bandwidth and also noise performance analysis. So what is bandwidth? Bandwidth measures the information carrying capacity of a transmission channel. And since AM and FM have both different bandwidth, we can differentiate that FM uses the formula 2 times B, where B is the highest frequency component of the message signal, while FM uses the Carson's rule formula, which is the bandwidth is 2 times the peak frequency deviation plus with the frequency of the message signal. While FM has an additional type which differs from AM, it has two types of bandwidth. It has NBFM, which is narrow band FM, and also wide band FM, WBFM. Narrowband FM is similar to AM, while wideband FM is broadly used in broadcasting because it uses larger bandwidth. And with larger bandwidth, we have better sound quality and also noise immunity. However, it uses more power. Moving on to noise performance analysis. So noise is electrical disturbances that interferes with the signal transmission. It is critical for reliable information recovery because we want to know how much recovery we need for a certain noise disturbance. So the key metric for noise performance analysis is signal to noise ratio, SNR, which is the strength of the desired signal versus the background noise. So the major differences between AM and FM noise is AM noises has poor noise immunity, while FM has a more superior noise immunity. FM has a more superior noise immunity due to its protective mechanisms, which are the limitations in circuitry and also the non-linear demodulation. The limitation in circuitry removes the amplitude variations in the circuit, and also for the non-linear demodulation, frequency-based detection ignores the amplitude noise, making sure that all the sound quality is at best. Moving on to the theoretical background, so we need to know what is modulation, demodulation, baseband signals, and also passband signals. So modulation is the systematic alteration of the carrier signal properties, parameters based on the information message signal. So the properties RS data either in amplitude, frequency, or phase based on the message signal. So the purpose of modulation is to enable transmission of low frequency signals over long distances. So what we need to also know, what is carrier signal. Carrier signal is a high frequency signal wave, but it is an empty wave. It has no carrying abilities. However, message signal is a baseband signal that contains the actual data to be transmitted. For modulation, we encode the information onto carrier at transmitter. However, demodulation is a reverse process. It extracts the original message at the receiver. Moving on to baseband signal. So baseband signal is an original information signal in the form of audio, video, or data. It has low frequency range, typically in the range of 0 Hz to 20 kHz for an audio. And its characteristics is it is suitable for storage. However, it has poor long distance transmission because it is easily attenuated. Due to its property that is easily attenuated, it requires an impractical antenna which is large. For passband signal, it's created by shifting the baseband to higher frequencies via modulation. Unlike baseband, the characteristics for passband is it is efficient for wireless transmission. It can share frequency spectrums and it can travel long distances. And due to its convenience in long distance traveling, we can use a practical size antenna. We would not use a long antenna like in bus, like for baseband signals. That is all for me. I will pass the presentation to my other group members, Lim Wei Chuan.
Good afternoon, everyone. I am Lee Wei Chen. Today, my title is I'm going to teach about is AM and FM modulation simulation, bandwidth and noise performance analysis. On to the next slide. This is the amplitude modulation and frequency modulation. I'm going to talk about principal generation and comparison. So I will cover why modulation is needed, how AM and FM works, and finally compare their performance and characteristics. So first, why modulation is needed? Modulation is the process of transferring a low frequency baseband signal, such as audio, onto a high frequency carrier. This allows signal to travel long distance efficiently and reduce attenuation during the transmission. As you can see beside here, it's the diagram of the baseband signal. Next, I'm going to talk more about amplitude modulation. In amplitude modulation, the amplitude of the carrier signal varies according to the message signal while the frequency remains constant. The information is stored in the envelope of the waveform, which makes AM easy to generate demodulate. Next, on to the AM characteristics. The modulation index M controls the depth modulation. AM requires a bandwidth equal twice the message frequency, making it bandwidth efficient. However, AM is highly sensitive to noise because noise directly affects signal amplitude. Next, frequency modulation. In frequency modulation, the frequency of the carrier signal varies with the message signal, while the amplitude remains constant. Since most noise affects amplitude, FM provides much better noise immunity compared to AM. So as you can see here, the message signal with the carrier signal, then frequency modulated signal, it's maintained. On to the next type, FM types and AM versus FM. So FM can be classified into narrow band FM and wide band FM. Wide band FM follow Carson rule and occupies small bandwidth, but it produces higher audio quality. In summary, AM is simple and very efficient, or FM offers superior noise immunity and clarify, which is why it is used in modern broadcasting. So yeah, all are shown here. The diagram here is also the comparison between AM and FM. And I think that's all from me. Thank you very much.
Hello everyone, I am Kamalia Sofia and I will be explaining the bandwidth and noise performance of two common modulation techniques, which is amplitude modulation and frequency modulation. These concepts are important in understanding how communication systems transmit information and how well they perform in real-world environments. First, what is bandwidth? Bandwidth refers to the range of frequencies a signal occupies in a transmission channel. It determines how much information can be transmitted through the system. In general, a wider bandwidth allows more data or higher quality signals to be carried, while a narrower bandwidth limits the amount of information that can be transmitted. In amplitude modulation, information is transmitted by varying the amplitude of the carrier signal while the carrier frequency remains constant. The bandwidth of an AM signal is determined by the highest frequency present in the message signal. Since the signal only spreads slightly around the carrier frequency, AM occupies a relatively small frequency range. This makes AM more efficient in terms of spectrum usage, allowing more communication channels to operate within the same frequency band. However, the limited bandwidth also restricts the amount of information that can be transmitted. In frequency modulation, information is transmitted by continuously varying the carrier frequency according to the message signal. This causes the FM signal to spread over a wider range of frequency compared to AM. The required bandwidth depends on both the message frequency and the amount of frequency deviation applied. Therefore, the Carson rule is commonly used to estimate the bandwidth of an FM signal. While this wider bandwidth reduces spectrum efficiency, it also enables better signal quality and improves the resistance to noise in practical communication systems. Now, let's move on to noise. What is noise? It refers to the unwanted electrical disturbances that interfere with a communication signal. It can distort or mask the original message, making communication less reliable. Noise is always present in real systems and can come from sources such as electronic components, interference from nearby signals, and also the environmental effects like the weather or electrical equipment. For the noise performance of AM signals are highly sensitive to noise because the information is stored in the amplitude of the carrier signal. Any external noise that affects the signal amplitude directly distorts the transmitted information. As a result, even moderated noise levels can significantly degrade AM signal quality, and this often leads to distortion or loss of clarity in the received signal, especially in environments with strong interference or electrical noise. Moving on to the noise performance of FM. FM signals provide better noise performance because the information is carried in frequency variations rather than amplitude. Most noise affects the amplitude of a signal, which means it has less impact on the encoded information in FM. In addition, FM receivers use amplitude limiting circuits to suppress amplitude fluctuations before demodulation. This allows the receiver to recover the original message more accurately even when noise is present, resulting in clearer and more reliable signal reception. In summary, AM requires less bandwidth but is more susceptible to noise, while FM uses a wider bandwidth to achieve better noise immunity and signal quality. This trade-off explains why AM is often used where spectrum efficiency is important, and FM is preferred for applications that require clearer and more reliable communications such as high-quality audio broadcasting.
Hi, I'm Lou, and I'm from Group 6. So today, I would like to talk about amplitude modulation and frequency modulation. So for part 1, I will talk about some recent advancement and societal impact for this AM/FM, this wave. So first, let's talk about the hybrid radio. So think of this as a radio with a brand. In the past, like if you drove too far from a station, then you would just get a static in your radio. So now, modern car system use hybrid technology to detect when a signal is weak and automatically switch to an internet stream of the same station. And you also can get to see the high definition album, art, and real-time traffic updates right on your car screen, all while using the reliable FM backbones. So next, even more exciting is the 5G broadcasting. So imagine watching a live sports event on your phone or your TV or tablet in a crowded stadium or any other crowded space without using a single byte of your expensive data plan. So By applying the FM style one-to-many broadcasting to 5G networks, the towers can send high quality videos and audio to everyone at once without the networking crashing. So it's the efficient of the old school radio meeting the speed of the future. And for the societal impact, so why does this matter? Because radio is our most resilient lifeline. So like during floods or power outage, when the internet fails and we cannot connect to the internet, so FM radio still stays on. It requires very little power and can like reach remote village. It can reach a far distance from the transmitter and where the fiber cables cannot do that. So this ensuring that every citizen or every flood victims or any other victims, no matter how far away, has access to the education and emergency news for free. So for part two, I will share some misconception about this. So first is healthy and safety, and let's address a common fear like, do this radio wave cause cancer? The answer is no. Science tells that AM and FM wave are not ionizing. This means they don't have enough energy to break our DNA or damage our cells, unlike X-rays or heavy UV light. So they are essentially invisible ripples of energy that pass through us safely. So this regulated by the very strict safety laws to ensure they never cause harm to us. So finally, let's tackle a big technical myth. So is digital always better than analog? So while the digital signal like Spotify, RQ, and they have a major weakness called the cliff effect. So if the signal drop just a little bit, the audio will cut out completely silence. But AM and FM are different. They use graceful degradation, and this means that during a massive storm or if you are very far away, the signal might get fuzzy or static feel, but we can still hear the emergency broadcast or the news. So in a life or death situation, a noisy signal is much better than absolutely no signal at all. So this is why analog radio remains the gold standard for public safety. So in conclusion, AM and FM are not just relics of the past. They are evolving through 5G and hybrid technology, and they remain our most reliable safety net during disaster, and they are scientifically proven to be safe for our health. So next time you tune in, either FM or AM, remember we are connected to a masterpiece of engineering that is working to keep you safe and informed. So thanks for watching, and please help us to fill the Google form provided. Thank you.